Yeah, Kieran, do you want to turn on?
Got it.
Okay, welcome to our Tuesday seminar for the 7th of June. And I'm delighted to welcome back to Cambridge a very old friend, Claudia Diaz from Leuven, who's going to be giving us a talk on reward sharing for Mixnets. Claudia, you have the floor.
Thank you very much, Ross, and thanks a lot for the invitation. So the work I'm presenting today is based on a joint paper with Halpin and Aggelos Kyiaias. The paper is already available online in the link that you can see there. And we are hoping that it will appear published in the next few days in the MIT Journal of Cryptoeconomic Systems. It's about to come out at any moment. This work is in the context of the NIM Technologies company, which has developed a NIM system that is basically implementing the reward scheme that I'm going to present today. Okay, so this is rewards for reward sharing for Mixnets. So very briefly, what is a Mixnet? It's a type of anonymous communication network. An anonymous communication network, typically what it does is that instead of sending messages directly from the sender to the receiver, these messages are relayed through a number of intermediaries, such that it is very difficult to trace the packet and understand or infer who is communicating with who. Now, I'm saying it's an overlay network, so that means that whenever we have a kind of a simple line in this network of communication, this is actually going through the internet. So it's basically from the perspective of the internet, this is an end-to-end communication for every single hop. Okay. So as I said, in anonymous communication networks, the trick is to relay messages via multiple hops, multiple intermediaries. And each of these intermediaries will strip a layer of encryption in order to find the next destination, the next hop. So who chooses these hops is actually the source. This is why these systems are what is called source routed. So that means that the sender of the message will package the data with multiple layers of encryption, one for each of the intermediaries in the route. And then when this message is being relayed, each intermediary will strip one layer of encryption and to find the next hop. So what I've said so far is very similar for both Mixnets and onion routing, for those of you who are familiar with Tor. But there is also some important differences. So Mixnets are actually packet-based. So that means that instead of basically establishing a circuit for a session and then sending all the packets back and forth to this circuit until the session is over, here every packet has routing information in the headers and is treated independently. And then not only that, but every one of these intermediaries collects a number of packets and then reorders them, such as the order of packets coming out is not the same as packets coming in, and you cannot trivially correlate packets based on timing information, which you would be able to do even if there is a cryptographic transformation, if there is no reordering. And then you have to put these mixes together into a network in order to have multi-hop routing. And in NIM, we are using a layer structure with uniform routing. That means that there is a set of mixes that are the first layer, and a set that is the second, and a set that is the third, and packets always go through the same order, meaning that they first will go through a mix in the first layer, then in the second, then in the third, and from any one of these, any successor is equally likely. There's reasons why this is a good choice. I'm happy to get into them if people are interested later on. Okay, so those are mixnets. So why do we want to have an incentivized mixnet, right? So a big reason is scalability, in the sense that you want to have a system that if it's successful and if there is demand and people want to use it, you should be able to grow your capacity in order to serve demand, arbitrarily large demand. So in volunteer operated networks such as Tor, the pool of volunteers is kind of inelastic. So you need to find people who have the skills, the capacity, the resources, the time, the money to run this operation, these nodes, these relays that actually make the infrastructure, bearing the operational costs and doing it just out of conviction or out of wanting to help. This works, but it works to some extent. If we look at Tor, we see that it actually grew steadily for 15 years, not for 10 years, up to 7,000 nodes, which is a very decent size. But from that point on, it has been kind of static. It hasn't grown any further. because I mean, yeah, there is so many people who are capable and willing to provide these services, and it's not that you can grow this pool infinitely. Also, it's not reasonable really to think that you can run a whole infrastructure for millions of people just on a volunteer, using volunteers for provision. So the idea with an incentivized network is that the extra income that you get when there is demand for the service can fund the growth needed to service this increased demand. And effectively what it creates is a market for consuming private bandwidth and providing private bandwidth. So you have some people that provide the bandwidth, some people that consume it. Of course, it's a big question to what extent people will be willing to pay for these services. But if we think about the VPN market, for example, this is a pretty big market and people seem to be willing to pay some dollars per month in order to protect their network to some extent. Of course, this offers a much bigger protection than a VPN. So we want to scale, not just add nodes, but also these nodes, they have to provide some quality of service. In a mixnet, quality of service is mainly about not losing packets because it's source routed. So the source has to prepare this packet. It has to go through these intermediaries. If one of the intermediaries is not offline or is unable to process the packet because it's overloaded, then the packet is lost and then you have to retransmit, and that causes like quite some degradation of the service. So that kind of discards peer-to-peer, some of the solutions in this space, which are based on peer-to-peer architectures, where each of the peers is both a user and a provider for others. So those scale naturally with the number of users, but they have plenty of problems, from eclipse attacks to difficult to guarantee quality of service and so on. So instead, we have a model where we distinguish professionalized providers that are paid for the work that they do and consumers that pay for the service that they get. Okay, and this distinction also allows us to have different requirements and properties for these different participants, in the sense that we want to provide as much privacy as possible for consumers who are paying for the service, while in the case of intermediaries, we want them to be verifiable and transparent and that we can check that they are doing a good job. This is not possible when you have kind of symmetric systems where everyone is both a user and intermediary, because you have a conflict in which protecting their own inputs means that they are less verifiable towards others when they are processing the inputs of other people. So to summarize, the goal of the incentives is to basically be able to have a mixnet that is as big as necessary to route all the demand and that is populated with reliable mixed nodes. So yeah, the size is driven by the load. And in terms of the reliability, the idea is that we want to have nodes compete on quality, such that the system can, over time, select the best performing nodes while weeding out the weaker ones. Scalability is not the only reason to have incentivized networks. There is also the issue of Sybil attacks. So if you think about it, like in anonymity networks, you are routing things through multiple intermediaries in order to achieve, to have a protection of who talks to whom, to have anonymity properties. But in order to achieve that, you need that at least one of the intermediaries in your route has to be honest. If the adversary controls every intermediary between you and your recipient, then they will be able to know the internal information of these adversarial nodes, and then they will be able to reconstruct the path, and then you don't get the properties that the system is meant to provide. So how can we prevent the adversary from fully capturing many routes? Of course, if the adversary has a number of malicious nodes, they will capture some routes, but we want to limit this as much as possible. We want to make it as costly and as difficult as possible. So in volunteer networks where you have variable node capacity, so this is the case of Tor, it is enough for an adversary to set up a number of high bandwidth nodes in order to route a large fraction of routes, right? And this actually, there was some reports that apparently there was some entity running several hundred nodes. There was some reports. I'm not sure there's many details known, but it seems that someone was doing exactly that. Of course, you cannot be too obvious, because if you set them all up in the same IP subnet or at the same time, it kind of, the people who are running the directory authorities might notice, but if you do it a bit over time, slowly, having nodes in different regions and so on, you would be able to, over time, have as many as you are willing to pay for. The cost is basically the cost of the bandwidth and the nodes and the setup. If you use uniform routing, that means that you don't take into account different capacities. then that removes the high bandwidth advantage. So now I cannot just put a few big nodes, I have to put many nodes. So if node number is kind of more of a limitation than capacity, that raises the bar a little bit. Of course, in mixnets, you can add more layers, more longer routes, more intermediaries, because every intermediary has to be corrupted in a mixnet in order to control the full path. This is different from Tor, where first and last can kind of establish that they are on the same path and de-anonymize the connection. In mixnets, because it's packet-based, you need to control all the intermediaries. But of course, adding layers has a big impact on latency and resources, because yeah, you will make it slower and you will consume more CPU and bandwidth and so on. So what can we do to raise the cost of Sybil attacks such that we select nodes to participate in this mixnet in a way that is decentralized? We don't want to have a trusted authority making decisions, and in a way that is conducive to having nodes that are kind of distinct. So the idea is that given an excess of candidates that are competing to provide the service, why there would be an excess? Okay, because there is money to be made. It's like a job. So there are rewards being given to people who provide the service. So we assume that there will be like a number of people who would be willing to provide this service in exchange for the rewards. So once you have an excess of candidates, the idea is to allow all the stakeholders of the system, and the stakeholders are the people who own any amount of the currency, the base currency of the system, of the base token. So you allow all of them to signal which nodes they want to support, they want to endorse for service provision. Okay, it's like the voting with your stake. And then we select the nodes for service provision proportionally to their stakeholder support. Okay, so the nodes that are more popular among stakeholders will be selected more frequently than the nodes that are less popular among stakeholders. So with this mechanism now, if you're a Sybil adversary and you want to take over a large part of the network, it's not only that you need to set up many nodes, which you had to do before as well, but you have to, this node, the fact that they exist doesn't mean that they are going to be routing packets in the system. If you want them to route packets in the system, they need to be selected. That means they need to have a stakeholder support. So either you as adversary buy a lot of stake in order to support your own nodes. So this could be very expensive depending on the value of the system, or you need to convince other stakeholders to provide support to you, to your nodes, to each one of your individual malicious nodes, which can be very effortful because you're also competing with others. So it's not like the support is there just for free for you to take. So we basically conceptualize a stake as reputation in a way, because this stakeholder support for mixed nodes, they has to be meaningful in some way. Like if there would be unlimited amounts of it, for example, it wouldn't mean anything, and the adversary could just manufacture support for all the adversarial nodes. So it has to be a limited supply, and nodes have to compete for it, right? And then the stakeholders have to have some skin in the game. That if they have to win something by having pro-social behavior, in the sense that they make decisions, when they make decisions that are good for the network, they should also benefit from making those decisions and contributing with their input in a way. So basically, we need to incentivize stakeholders to support the best nodes. Which are the best nodes? Well, first of all, reliability and performance, so very high uptime and no packet loss. If you don't have reliable nodes, then the system will not take off because people will not use it if it's too slow and if there is too much packet loss. Besides that, you want it to be cost effective, so that if people are able to run this infrastructure spending less money, so that's desirable. And then there is a fluffier kind of trust in the operator, less encoded properties, such as, for example, if the node has been living for a very long time, then you might think that it's possible that the node stays longer, so that if you put your support on that node, when you come back, you will have rewards. Otherwise, if the person deletes the node, then by the time you come back, you supported someone that was not working, so you didn't get any rewards. The more the operators take, the more rewards as well. So skin in the game from the operator is also valued positively. And then you might look into things like, is the operator a person that is part of the community? Do they contribute? Are they associated to entities that have some sort of trust out of the system, like, I don't know, non-government organizations interested in privacy and so on. So basically, we express is like a staking system, and reputation is represented by this total stake associated to a node. And this includes both the stake bonded by the operator and the stake delegated from other stakeholders to support this node. Okay. Now, reputation is not increasing infinitely. It's actually maxes out at a point that we call the stake saturation point. Okay, and this is done in order to prevent over-concentration of reputation / stake on too few nodes, because we need to have a network of a certain size in order to meet demand. So we want to ensure that stakeholders are spreading their support over a sufficient number of nodes to populate the network. So basically, we have the set of nodes, they have the reputation, that is the aggregation of bonded and delegated stake. And then based on this stake, we do a sampling. Every hour, the mixnet is reconstituted, sampling a fresh set of nodes that are going to do work in the network for the next time period. You need to reconstitute not only for purposes, anything related to rewards, but also related to forward security. You need to refresh keys in order to prevent that old messages can still be traced and decrypted. So you need to have a key refresh. So this is now this key refresh is also refreshing not only the keys of the nodes, but also which nodes are in the network, so that we can do this sampling and have a dynamic system. So as we can see here, if a node has a lot of reputation, nodes with lots of reputation will be more likely to participate in the network, while nodes with little reputation, this is the little dots, they are less likely to participate, although they will be selected sometimes. Okay. Now, we don't just define the number of nodes that will be active. We actually have kind of two parameters: the number of nodes that are rewarded, which is the number of nodes that we're encouraging to exist in the network. And then of those, maybe some of them are kept in standby, a standby set that is also rewarded at a lower rate. And this is the idea of this is that growing the K and having to reallocate reputation is very costly. A lot of people have to take action. So you want to have flexibility to make the network bigger or smaller on short notice. So this standby set provides some room for growth without having to change the whole allocation of the whole staking state. Once they are working in the network, then there is they do the job, and then at the end of the day, there is some money to be given for the job. So if those that did the job with a good performance will receive a payment, and then they will share this payment between the operator and all the delegates that supported the node. Okay. So this system enables decentralized decision making in the sense that we don't have a centralized entity, trusted entity making decisions on who is in the network, who is out of the network, and how much they get rewarded. So it's collective. But in order to have all these stakeholders collectively making decisions, we need them to see the same information. So we need to have a consistent view of the network information. What are the network parameters? What is the staking state? What are the nodes that exist? And what are all the transactions and operations? And everybody has to be able to verify the authenticity and integrity of these transactions. So this is what we use the blockchain for. This is how the blockchain comes into play here. We use the blockchain as a broadcast channel. It's a public record of all the node registrations that exist. What are the right keys, the right addresses, the network parameters, who is staking on whom, who's delegating to whom, and the node performance measurements are also published in the blockchain. So this allows basically all the information that is needed to make decisions should be available to all the stakeholders, and blockchains provide availability and integrity in order to protect this information. There are also smart contracts in this blockchain that execute the reward algorithms and that might grow the network or shrink it if necessary to adjust to demand. The changes of parameters, they can be governed through governance mechanisms for updating software and network parameters. So these blockchains also provide some governance capabilities in order to manage the system. And oops. And the last element I want to bring on the table is the bootstrapping. So there is a chicken and egg, typically there's a chicken and egg problem with anonymity networks, which is that anonymity loves company. The more user base in a system, the more anonymity you have in the system. So that means that in the beginning, when the system is new and is still, the adoption is still not very high, the anonymity is also not so high. So that means that in the beginning, you don't have a big incentive to pay because you're not getting as much privacy as you will get if there was a big user base. So that means little income to fund operations. If you don't have much income to fund operations, maybe you cannot have very high quality nodes from the start, which would preclude usage growth and keep you kind of not unable to take off. So the idea is that We can have a kind of a reserve because there is a Coinbase in the system. So you can have a part of this token supply can be used for funding the bootstrapping of the system. So the idea is that, yeah, so a part of this token supply is locked in a reserve, and this reserve is slowly releasing rewards over time. And the idea is that these rewards kind of decline over time. And over time, as the user base grows, you should have user fees take over. Obviously, this bootstrapping reserve will get you for a few years running in the system. It will not be forever. If you only have the bootstrapping reserve, then, I mean, at some point you need to have usage and you need to have fees in the system to have long-term sustainability. This is a little bit similar to Bitcoin, that you have mining in the beginning, providing most of the rewards, and then fees afterwards taking over. But I mean, the analogy is not perfect, and there are some important differences. I can get into that if people are interested. So putting everything together, this is how the economic model looks like. So we have the stakeholders that are anybody who has NIM tokens. They can use these NIM tokens to use the system to send private messages. So these would, the tokens that they spend would be part of the income from fees in the system. This income from fees will be divided between the different providers. So the Mixnet is the biggest component, the kind of the core component to provide private communications. But there's also two other components that I will talk about in a moment that provide auxiliary, important auxiliary functions as well, which are gateways and validators, and they will take also some of this income from fees. The fees that are destined for the Mixnet are added to the reserve that is there for bootstrapping that also emits some rewards. So every time period, we will have a budget of rewards that we can distribute to the Mixnet. And then the rewards algorithm determines how many rewards are given to each of these mixed nodes on the basis of a number of parameters that I will get into details in a moment. And then these mixed nodes will share the rewards they receive between the operator and the delegates. And these are, again, the stakeholders that the money they were not using to spend on fees in this moment, they were staking on the system to contribute to the management of the system and to make some rewards for the work of actually helping with the selection and the reputation management. This is how it looks from a functional point of view. So here we have the Mixnet shuffling package. We might have some standby nodes that were selected to be rewarded, but not to be active in this epoch. And then we might have additional nodes that were not selected. And then users connect via gateways to send packets. And then we have the validators maintaining the blockchain. So the validators, their job is to add blocks to this blockchain, to keep the network state and execute the smart contracts. They are effectively, from the perspective of the Mixnet, they are a third-party service that provides this kind of blockchain service. It could be any blockchain, I mean, we have our own, but it could be any third-party blockchain that allows to execute the smart contracts that are necessary for the system would be valid as a system. So it's kind of an auxiliary service. They are paid by transaction fees. So anybody writing to this blockchain has to pay some fees to write the information. So this includes the nodes that get registrations, the people delegating their stake to support nodes, the people making transactions to buy bandwidth. All of them, they have to do operations, interaction with this blockchain, and these interactions are what funds the validators. Now, the validators, this blockchain is also not exclusive for the NIM Mixnet. It's actually a general purpose WebAssembly smart contract platform. Everybody can use it, can upload contracts. And so that means that the validators are not exclusively serving this system, but they can support other services and be paid for them. And then the other entities, gateways, they act as an interface between the user and the Mixnet. They collect the user payments, and then they keep count of how much of this budget was already consumed by users. When users receive packets, if they are not online, they can cache the received packets. And optionally, some of these gateways could implement censorship circumvention access if NIM would be blocked in some jurisdictions. They are different from the Mixnet in the sense that they are chosen by the user rather than being automatically assigned. This is in part because, yeah, I mean, for example, if you have censorship, if you would assign them automatically, maybe people would not be able to reach the gateway that they can use because, yeah, not all of them are accessible or whatever. So they have a bit of a special function, and they are paid by a fraction of the bandwidth fees. So when users are paying for bandwidth, the gateways will take a cut from that, from their specific users. So if I sign up with a gateway and I'm using the system, that specific gateway will take a cut. So gateways in a way compete for users, and they might, because the more users they have, the more income they get, and they may offer additional services in order to attract more users. So if we go into the components of the reward scheme, so the first thing we have is node registration. So people who want to write node, they want to operate nodes, they will register the nodes. They have to lock an amount of token in order to register the node. Currently, this is 100 NIMs, which corresponds to about $30, $40. So it's not like a big, amount. And then they also declare what is the node operational cost and what is the profit margin they intend to take from the delegates who support the node. Once the nodes have been registered, then all the stakeholders can choose which nodes to delegate to, okay? And as they delegate their stake to nodes, they increase their reputation. And as I said, this is up to a maximum. So it maxes out at the stake saturation point, which is basically when you have, the target number of nodes, all of them are saturated. That would be kind of what defines the stake saturation point, is dependent on the available staking supply. And then once you have this state that you have all these nodes and they have some reputation, now you're selecting them for the mixnet. This is weighted sampling without replacements, proportional to reputation, effectively. So the first LW nodes that you sample are populating the mixnet of L layers with W nodes per layer. And then the next K minus W, K being the parameter of the reward algorithm, those are kept as a spare capacity and rewarded at a lower rate. And of course, the ones that are not selected, they will not be rewarded for this epoch, but maybe they are lucky and they get selected in the next. I'm not gonna go into this. This is just to show you how different stake distributions will result in different probabilities of being active or being in standby. So for example, if you have 50% saturation, what is your chance of being active, or your chance of being in standby, or your chance of not being selected? Well, it depends not only on you, but on everybody else, how competitive it is. So it can be, there are kind of different situations, but of course, the more stake you have, the more chances you have of serving in the network, of participating in the network. And the less you have, the less stake, the more difficult, the less frequently you will be active. So, okay, and once we have all these nodes selected and working in the mixnet, then we need to see whether they are doing the job properly, okay? So we need to have some sort of performance measurement. The performance measurement is basically an estimation of what is the percentage of packets that the node is correctly routing. Is it routing 100% of the packets, meaning that all the packets that users have sent to this node have been, correctly decrypted and sent to the next destination, or whether the node was offline or overloaded or unable to handle all the packets, right? So we are working, this is work in progress. We're working on a decentralized solution that uses kind of the concept of secret shoppers to sample and estimate node performance. So this is kind of still, we have a pretty developed system, but is not yet, we haven't yet fleshed it out completely. So this is in the workings. And for now, the placeholder solution is that the validators are sending the packets through all the nodes and kind of publishing their results. Regardless of how you obtain this performance, in the end, what you have is a score between 0 and 1 that represents the estimated fraction of correctly routed packets per node. So, okay, so now you have a bunch of nodes, you know how well they did, and now you need to distribute money to them. There's the reward. So what is the budget that you have to distribute? It comes from two sources, as we said. So one is the mixed mining pool, the reserve. In our case, there is a quarter of the total amount of token is locked into this pool. And every month, 2% is made available. So in the first month, basically 5 million, and in subsequent months, 2% of whatever is left. And allocate not all the rewards that are made available. So in this case, the 5 million, not all of them are necessarily distributed. So some of them might not be allocated, and those that are not allocated, they are fed back to the reserve, right? And distributed in the future, the next month, 2% of whatever is left will be taken. So this softens the exponential decay beyond what would be like if you just had a pure 2% emission. And then for the bandwidth fees, we propose a dynamic posted price approach that basically considers the operational costs of the set of nodes and then computes the bandwidth price in order to cover all the costs in expectation, plus a tau fee, which is on top of the cost, what is the kind of profit that would be made by the system for the service provision. And then once you have this, then you need to have algorithms for distributing the budget among the nodes, and then for distributing the nodes, the rewards received for a specific node between the operator and the delegates. So let's look now into this. This is how it looks like for the distribution of rewards to nodes. So basically, this is what a node will get. So this is the total budget of rewards that is there for the full epoch, for the full set of nodes. Okay, so the rest, all of this is the fraction of this budget that is going to be allocated to the specific node. Okay, so this is dependent on the performance score. So if you have a performance score of 100%, then you are not taking any loss in the rewards that you receive. Anything below 100% is going to proportionally degrade the rewards that you get as a node. Okay. Then the next is the amount of stake saturation. So this is again between 0 and 1. So if you have 1, that means that you have fully saturated, you have the maximum reputation, and then you also get maximum rewards. If you have less than maximum reputations, then the rewards are scaled down accordingly. And then we have this element in the middle, which is basically rewarding nodes on the basis of the share of work that they did for the network, partly, and partly on the basis of the operator stake. So that's basically the skin of the game of the operator. Okay, and this parameter alpha is a parameter that controls the fraction that is due to share of work and the fraction that is due to the amount of the pledge. So the share of work, to be very simple, if we would have K nodes and all of them would be active in the network, then the share of work of each of the nodes would be 1 over K. Okay, so it's of all the work that the network is doing, how much are you doing as a node? If you would have uniform selection, I mean, all K working, 1 over K. If you have a standby and an active, then this varies. If you're active, you will have a share of work. And if you're a standby, you will have a different share of work. And we have some parameter there to compute one on the other with a factor that means that when you're a standby, you're considered to do 10% of the work of an active node. Okay, but just to give you a sense that this is in the order of 1 over K, right? Which would be would make sense because you're giving rewards to K nodes and this is total budget. So normally, like roughly, you would think that each of them would get 1 over K at most. Right? And then this second part here, this has to do with the pledge saturation. So the more you want to favor that people who have more skin in the game, they have kind of a bigger weight in order to get more rewards. So this is, we call it the Sybil protection factor, because thanks to this, having an alpha bigger than 0 means that if I have an amount of stake and I put it all in one node, this is how I get most rewards. And if I try to take my stake and use it to set up as many nodes as possible, then in the end, I'm not going to make more rewards. I'm actually going to make less because the sum of the rewards from each of the nodes that I get with the stake that I put is going to be less than if I would put everything together into one node. So this basically disincentivizes people from partitioning their stake in order to run multiple nodes. There's a financial penalty for doing that. Currently, we're using a 0.3 for this parameter. So that means that about 20% is given by of this element is given by the pledge, and 80% by whether you're active or in reserve. Okay. So the properties of this reward algorithm is that the rewards are proportional to performance, reputation, and partly the operator pledge. The sum might not be complete because if there is low performance or low reputation, you don't distribute everything. In fact, the further you are from the equilibrium, the less you distribute. The closer you are to the equilibrium, the more you distribute. The equilibrium is never really achievable because that would involve all the stake in the system being staked in exactly K nodes and so on. So this is kind of it's a gravity point that pulls everyone towards that state, but normally in practice, you never quite at that exact point. And then we have these two parameters, K and alpha. K controls the size of the network. It caps the incentive so that you have enough spread outs to have K nodes, and the Sybil protection. The higher it is, the more financial penalty for operators that partition their stake. Once you have a node has received the rewards, now they have to distribute it between the operator and the delegates. So the first thing you do is that you subtract the declared node cost, and this is given to the operator. Okay, so the profit is the rewards received by the node after costs. Okay, so the cost is given to the operator, refunded, assuming there is if of course you receive less than the cost, then you distribute nothing to the delegates. Everything is given to the operator. If there is a positive profit, meaning that the costs are not as high as the rewards, then the operator, in addition to the refunding, will get a fraction of the profit that is determined by the profit margin. So the profit margin is given to the operator of the total profit. And then the fraction of the rest that is proportional to the operator's stake, right? So this is the total node stake. This is the part of a stake that the operator put, the pledge. So this part corresponds to the operator by stake, and then the part that corresponds from the profit margin. And the delegates, they just get this part. So the percentage of a stake that they have of the total node stake, once you have taken out the profit margin, that's the part that you give to delegates. So the properties of this is that we are prioritizing the coverage of operational costs before any profits are distributed. This makes nodes compete on cost effectiveness and profit margin. So the paper has a proof that shows that if you are untruthful in your cost declarations, either too high or too low, you're actually not making more. So it's not advantageous to lie. And profit margins is more of a market mechanism. So it's a price discovery. It's not price, but it's a margin discovery. So different nodes will have to try to what extent they are able to attract delegates with higher, lower profit margins, depending also on their reputation, on their whether they are well known or not, on their other parameters of the node, the cost and so on. And yeah, once a node is oversaturated, then all the delegates start receiving fewer rewards because the rewards are capped and they are more to distribute now, so they each get a smaller piece of the pie. So that incentivizes them to move their support somewhere else. We have implemented a simulator. It's available publicly, so you are invited to play with it. It basically implements the reward distributions, and we are able to generate scenarios with different staking distributions, demands, network parameters, and then we can run the rewards and see what the distributions look like. So this is very useful to test the impact of parameter changes and to see what happens with different staking behaviors. So we have used it extensively, and we keep using it extensively to try out any changes before we propose them to the real system. Just some examples. I'm a bit out of time. I have a bunch of slides with graphs. I mean, I can also go quickly over this, and then if people are interested, go more in detail. This is just to show you what the kind of things we do with these empirical results. This is just examples that are from the paper, and actually the system has now evolved, so the parameters are a bit different. So this is not exactly reflecting the exact results you would get now with the current parameters, but the dynamics of the reward algorithm are still the same. So we considered like a very skewed distribution of pledges over nodes. So some people have a lot of money, whales, and they have fully saturated nodes. The others, probably many of them have small pledges. And then in terms of reputation, we have from the maximum to the minimum, and with all combinations of pledge. So some of them have lots of reputation, low pledge, lots of reputation, high pledge. We want to have all the combinations in order to see how all these different nodes are doing. And then we consider two scenarios, one with low demand. Basically, the system has very little income from fees, so it's just living off the mixed mining pool, the bootstrapping reserve. And here we see that over time, after 5 years, so this is slowly declining. The budget of rewards that we have per month is slowly declining. These two lines show how much is distributed and how much is given back to the pool. We see that about half is distributed and half is not. This is dependent on the staking distribution. We are considering perfect performance in these examples. In the fast growing demand, after 3 years, there is like an exponential growth. And here we see that indeed there is like the fee income is growing. So the total income of the system is growing. And then we study like, okay, what happens if you have fast growth? What happens if you don't have much demand? How does the system behave over time? So then we can look at, okay, in the first year, in the last year, how are different nodes with different reputation faring? So for example, here we see that the top two figures are from the first year, from the initial year of the system. We see that the income is very similar in the beginning because the fees in the beginning are not so big. So we see that, yeah, the more reputation you have, the more rewards the node makes. And the level of rewards is very similar in the beginning. After 5 years, in the case where we have high demand, the nodes are still receiving rewards at the same level as before, because we have a sustainable system that now, we have created more nodes, but there is income from the user fees. So, everybody's getting paid. In this case here, we are not having anything more than the bootstrapping reserve. And we see that indeed the nodes are, after 5 years, these nodes are getting half the rewards they were getting in the beginning, because yeah, there is no income from fees. So the pool is getting depleted and there is less and less money. See, I mean, half the amount in after 5 years is not too bad, actually. Then part of this is going to the operator. So here we can see that this is correlated. If you have more pledge, this is the maximum pledge you can have. Only with the pledge you're saturating, then you have more rewards. Fewer rewards if you have a small pledge. But even with a small pledge, you can see that you would be able to make some 10,000 in rewards per year, which might, I mean, of course, this is for a given cost and a given profit margin and so on. Everything changes if you're changing parameters, but you see that you might have, even with a very small pledge, you might have some decent rewards that are enough for justifying the amount of work done to keep the node running. And then the rest of the rewards are given to the delegates. So this is how it evolves over 5 years in both scenarios. We see that if we don't have any income from fees, slowly it starts declining. So yeah, by the 5th year, people are getting basically half the amount that they were getting in the beginning. While if we have income from fees, then actually the rates of returns are growing. Why are the rates of return growing when the fees are in? Well, because you have the mass, NIM has a fixed token supply. So that means that if there is more income in the system, then there will be more income given per token that is staked in the system, because the amount of tokens doesn't change. So the denominator doesn't change. So if the numerator becomes bigger, then you have a bigger return per stake token. And this is how it looks like if you look at first year, last year in both the scenarios. Again, we can see that, yeah, of course, this is for the last year in the high bandwidth. We can see that, the returns can be quite significant if you are delegating to fully saturated nodes. Here you see that if you're delegated to nodes that are not having enough reputation, in all cases, then you get 0. So this is because these nodes, all the rewards they get are used to cover costs. So they don't have anything left to share with delegates. Okay, they're not getting so many rewards because they have low reputation. They don't get selected very often, and they still have running costs even if they are not doing the work. So that means that there is not so much to distribute. These are the parameters. I will not go into this, just for reference. And just to summarize, coming to the end, more or less, not too much over time. So we propose an economic model for incentivized mixnets that can create a market for private bandwidth that is able to scale if there is an increased demand in order to meet this demand. The incentive scheme promotes quality of service and cost effectiveness in the nodes. They have to compete to have good quality and to be cheap and to be trusted by the stakeholders. And it leverages staking. It uses a staking and a stake delegation as a form of node reputation. Then we use this node reputation in order to decide who is participating in provisioning the service. And then we give rewards proportionally to the performance and the reputation. You have to think that performance is actually more important here, in the sense that, yes, a node with more reputation will receive more rewards, but they will also have to share this reward with more delegates. So per delegate, the increase of rewards with reputation is substantial, but the performance is actually very substantial as well. And then, of course, this introduces the need for accurate performance estimations, which is non-trivial, but we have some solutions in the workings. And then with all of this, we can have a distribution of rewards that is algorithmic, and that can be executed without having any trusted central component that decides who participates in the system and who gets paid for it. And if you want all the details, the paper is available. So I think this is it for the presentation.
Thank you, Claudia. So I was just looking at your website and I see that although you're not offering the service yet, you've got 476 nodes up. I take it these are mostly nodes that you're running yourselves.
No, we are not running any nodes. These are community people. So actually, I mean, before launching the mainnet, which is the one that is currently operating, we had a series of test nets already for 2 years. And there was, during this period, there was like a community of people that already became interested in running, operating these nodes and so on. So yeah, this has been in creation, this community has been being created for some time. And I mean, we hope to grow it to have like a good, a good set of people who are capable and interested in running this system.
Okay, so you're already paying people for providing node service?
Yes. At the moment, the fees are not yet turned on because, I mean, of course, we want to encourage usage, and if we put a paywall in the beginning, this might be, we might make our task more difficult. So we want to make it free for use in the beginning. This is going to be like this for a few months at least. So the nodes are being paid from the Bootstrapping reserve at the moment. Right.
Okay. So when are you switching it on for public service?
So that will be dependent when we have integrations with applications that add value, so that we, so that is sensible to expect people to pay for the service. Right now, it's mostly for testing, playing around, getting to understand it. We don't have, I mean, there is some applications that run on top, so you can actually, I know people that are using the Mixnet for Telegram, for example, or that are using it for Kyiaias, so for chat applications. And, but yeah, and this is not like a custom integration that, we have a client that we can give to end users, that they just click a button and then they are part of the network. I mean, for now, this is in development.
Cool. Okay, Jana's had his hand up longest. Jana, do you want to ask? Jana?
Hey, okay, are you asking Jana?
Okay, if Jana is not there, Arno, do you want to ask your question?
Yeah, I do have a question. Can I ask?
Speak up.
Sure. I have the question like, I'm planning to do the mixed node as well. As of now, I have delegated. But, when I see the nodes guru has a lot of, mixed node.
Was it cut? I stopped hearing.
Yeah, the speaker has dropped out.
My apologies, I muted him. It's the user interface effect of Zoom, which is if you're muting somebody and they mute themselves, you end up muting the person next to them. So my apologies to the question asker. Start again at the beginning and unmute yourself.
Okay, yeah. Hey, all, this is Jana here. My question is, I see Nodes Guru comes up with different names like California, Singapore, and they are dominating. If I want to run the mixed node, I'm really worried. Will someone delegate to me or only to the Nodes Guru? So what is
yeah, I mean, of course, it's a reputation system, right? So you have a social human layer that has to work in a way. So the reason why Nodes Guru is so popular is because they are very active in the community. So they run some of the community channels, so people know them, people trust them, and people delegate to them. So that's why, I mean, now we need to kind of, we are trying to have activities so that we, for example, have people who want to run nodes, be able to have the spotlight, be able to have like some information about why they want to run the system, what is their interest, so that they are able to attract support from people. Now, you have to think that at the moment, with the current parameters, even if you have a few nodes that are very popular, in this case, Nodes Guru, the system is configured to have several hundred nodes in the system working. So even if your node has little stake, it will still be selected, because right now, the staking distribution is in such a way that even with little stake, you have high chances of selection. Of course, this depends on the distribution. If over time, more people have a good stake and more people than the hundreds that we are selecting for activity are having high stake, then it will become more competitive. And even if you have a good stake, sometimes you might not be selected. This is what I had here, right? So depending on the distribution, like right now we are a bit in this situation, right? So a lot of people, we don't have enough. I think the configuration, we're going to change it, but right now is 700. So we don't have enough nodes that have like high reputation to fill 700. So if you have anything more than the minimum, your probability of activity is 1, right? If you would have a more competitive system, then if you have little stake, then you're competing with not just 4 Nodes Guru, which don't take over the whole thing, but maybe 400 other people, then you might have more trouble getting a spot.
Understood. Thanks, Claudia.
Great. Thank you, Jana. Arno, do you want to go next? Would you care to unmute yourself and speak up? Arno Lebet?
I see the question in the chat, actually.
Okay, do you want to just answer it directly if Arno, for some reason...
The question says, in the chat says, won't the cost effectiveness incentive parameter lead to a concentration of nodes in countries, regions where the cost of operations is low? And if so, is it a challenge for the security resilience of the mixnet? That's a very good question. Indeed, I mean, if you would have, if the cost effectiveness would be such that, you know, there's this one place, this would be a problem. You have to think that cost effectiveness is not the only thing. Like I can have a more cost effective node than you, but maybe I have a higher profit margin and therefore delegates prefer you. Also, we have, I didn't talk at all about it, but we have, this is a different paper. This is the Verloc paper. I don't know if it was presented here already or it's going to be presented in the future. Verloc is actually implemented in the Mixnet, which means that we are able to verify the geolocation of nodes with some accuracy. So you can also have the global distribution of nodes as a criteria. So for example, if I am a stakeholder and I am worried about over-concentration in certain locations, I can delegate my stake to someone who's in a region that is underrepresented in order to have a higher global coverage. So while it, I guess the point is that while it might give some encouragement towards cheaper nodes, I don't think this is necessarily kind of completely biasing the network. And then, I mean, I see more questions here. I don't know if I should.
Yeah, Thomas Zacharias, do you want to go?
Yeah. Hi, Claudia.
Hi.
I'd like to ask, so at some point you mentioned that the quality of a node is going to play a role, whether you're going to discard the node or keep it for the whole maintenance of the system. So what are the metrics for that? What are the parameters for measuring quality?
So it's not so direct. It's not so direct. So basically, I mean, you're measuring the node, the quality parameter is simply percentage of packets processed. Are you online and processing packets and routing them? Or are you offline, or are you overloaded, dropping packets and not? This is the key thing, because this is source routed. So that means that I choose a path in advance and then I send my packet, right? So if any of these intermediaries is down, then this is causing a usability problem for me, because I have to then wait some time, see that the packet didn't arrive. You need to have like reliable transport and then send it again. So this is a big problem. So the key thing is the node processing, routing the packets, yes or no? Now, imagine a node is failing, okay? So a node has high reputation, So it gets selected to work in the mixnet, but then it's failing. It's offline, it's falling all the time. So what's going to happen is that this node is not going to receive many rewards. If it's offline all the time, it's going to receive 0. Okay. It still has high reputation. It still might get selected again. Now, the thing is that the people delegating to this node, if the node is consistently providing a bad performance, they are incentivized to move their support towards a better performing node, because this badly performing node is not yielding a reward, right? Or is yielding a smaller reward than a better performing node. So it's not that because you have bad reputation, I don't select you. It's because you have bad reputation, you get few rewards, and that drives away the support. But in the end, yeah, it's the support of stakeholders that will determine whether you get to participate or not. Does that make sense?
Yeah, I see the balance here. Yeah, thank you.
CGI bin had a question about whether debug mode, whether you could debug node performance like uptime. Do you want to speak up, or?
I see a question before that, actually, about the mixed mining being empty.
Yes, so this user has 2 questions.
Yeah. You can answer.
If the user wishes to remain anonymous, I suppose you'd better just answer the questions from the text.
Yeah, so the mixed mining pool is never empty, because it's you are taking 2% of whatever is left. So it's an exponential decay in a way, right? So you never have 0. You will end up having smaller and smaller amount. Think that it can also be replenished, actually. If you have a sudden increase in fees, income from fees, and you have a bad state in the network that is far from the equilibrium, you might be in a situation, and in some of the simulations it happens, you might be in a situation where you are putting more back to the pool than you took out, because you're putting back from the budget, which is the aggregation of the pool and the fees. So if the fees are huge, and then you're not distributing so much, you might replenish it for a few periods, and then you will not be replenishing for very long normally, because then things will adjust again, and you will mostly be taking money out. So it never depletes, but of course it slowly goes down. So it's kind of graceful. And then, is it possible to debug? I mean, I am not sure how the deployment is right now. I know that there was some talk about that it would be nice for people who want to set up a node, that they have some sort of setup that they are able to see that they have enough processing capacity and stuff like that. But I am not sure to what extent this is in place at the moment. I know it's on the wish list.
Oh, well. Well, many thanks for coming and giving us this talk, Claudia. We will look forward to seeing the thing being rolled out and being available live. And then, of course, that's the testing point. That's,
yeah.
You know,
I mean, you can already play with it for free now.
Well, as they say, battle plans never survive contact with the enemy. So I imagine once you're running live, you'll have to make quite a few changes. Yeah. And I'm always slightly skeptical about the ability of complex systems with lots of smart contracts to adapt quickly to market conditions. Yeah. But I mean, we will find out, right? It's an experimental system, so we'll find out if it's successful. I mean, I think at least it's a new opportunity, I think, for funding these kind of privacy systems that, you know, from the bottom up, kind of having a community of people interested in this. And let's see if this can be managed in a way that, you know, we all together kind of contribute to it and it somehow works. We'll find out. Yeah, it does. It does provide a new means of crowdsourced funding, and the last few years may have been you know, exceptionally good for that. Whether this will continue long term, yeah, as people get past the crypto bubble, remains to be seen. But if you can get a crowd-funded community that continues to support infrastructure, then that really would be a breakthrough. Yeah, that's many thanks for the talk, and I will just mention to our regulars that we have got 2 further seminars in the following week, in addition to a talk a week from today by Arwa Al-Alsadi of the Delft University of Technology on quantifying the lifespan of exploits and IoT malware. we've also got a talk this Friday at our usual security group meeting at 4 o'clock, where a couple of guys from Leakix will be talking about how we exploit internet services misconfiguration at scale. So a veritable feast of seminars for the end of term. And we hope to see many of you there. So thanks again, Claudia, and till next time.
Thank you very much. I hope to see you in person soon. I should visit sometime.
Look forward to it. Cheers then.
Thanks a lot. Bye-bye.
Bye.